Hello class. Today we're going to talk about something called direct variation. It connects directly with the lessons that we've been doing over functions, function notation, evaluating functions, determining whether or not a function is proportional or not. Today we're going to talk about direct variation. So our standard that we're looking at is 8.5a, which says we're going to represent linear proportional situations with tables, graphs, and equations in the form of y is equal to kx. So yesterday we talked about what this y is equal to kx is all about. So today we're going to find out more about that. Okay? So let's dive off into the lesson real quick. So let's say I gave you this square. How would you find its perimeter? How would you find its area? Well, if we remember what perimeter is nothing but the distance around an object. So it's you pick a spot on the figure and you walk all the way around it. That is perimeter. So basically for perimeter, since it's a square, if I know one side, I can multiply that value by 4 and I can find the perimeter of this particular square. Well, what about area? Well, area is talking about the stuff on the inside. Okay, so we need to make sure that we understand the difference between that. And to find the area of any two-dimensional shape like this, if it's a square, if it's a rectangle in shape, we're going to take its length and its width and multiply those together. But right now what I'd like for us to look at is I want to look at the perimeter. Okay, because we want to try to determine if this is if the values that we have in our t-chart vary directly. As one changes, does the other one change as well? So here's our square again. It's a little bit smaller, but it's still the idea of the square. So what if I said the side length of the square is 0? What would its perimeter be? Well, if we had a side length of 0, we wouldn't have a square at all, would we? So it would not have a perimeter. So its perimeter would be 0. But what if each of the sides were 2? 2, 2, 2, and 2. Okay, if that was the case, then we would do 2 times 4, or 2 plus 2 plus 2 plus 2, and get 8. Well, what if, instead of it being 2, what if they were 4? Okay, so 4, 4, 4, 4. Well, that's 4 4s, which actually gives you 16. Okay, well, what if it were 6? Well, that one, if I had a 6 there, that's going to be 4 6s, and 6 times 4 is 24. So I have a couple questions for you to answer now that we've completed the table. The first one is this a proportional relationship? Well, if you remember yesterday, we talked about whether or not a t-chart is proportional, and there's two conditions that it must meet. One, it must have the origin as one of its points, and it has to be consistent going down. Okay, so here it goes, add 8, add 8, add 8, add 2, add 2, add 2. Okay, so yes, it is consistent. So is it proportional? Yes. Okay, now what is the constant of proportionality? Okay, now I told you that the constant of proportionality, it's the same thing as slope. Okay, it's just in a constant of proportionality situation, which is y is equal to kx. There is no y-intercept, or there's a y-intercept of 0. It's not that there's no y-intercept, because the graph will cross at 0. It's just our y-intercept is 0, so we don't have any value there. Okay, so what is our constant of proportionality? Well, it's the delta y divided by delta x. So 8 divided by 2 is 4, or 4 over 1. Either one of those is acceptable. Now, if we write the equation, then we know that this is going to be y is equal to 4x, and then we have a y-intercept of 0, so it's just plus 0. So we just leave it as y is equal to 4x. You don't have to have the plus 0. Okay? So that's what we're looking at today. And if you look back at the standard that we had, we're looking at proportional relationships dealing with y is equal to kx, where k represents the constant of proportionality. Okay? Or it's the slope of the line if the line goes through 0, 0. So now when we look at some examples here, all of these show direct variation situations. So do you notice any similarities to proportional relationships, the ones that we talked about yesterday? Well, if you look at the graph, you'll notice there is a constant rate of change. They make a line, and it goes through the origin. You'll notice in this t-chart, our origin is part of our t-chart. And does it have a consistent relationship here? Well, here we've got 0, 6, but then I've got 6, 9, and then 9, 12. Well, if you'll notice over here, this is counting by ones. So if we added that 1 right in there, would that be the right thing? Yes, it would. Now we're counting by threes going down that T-chart. Okay, so that is a proportional relationship. If you look at all of these down here, you got y is equal to negative 3x, y is equal to x, y is equal to 2x. Well, looking at the graph, they all go through the origin. They're all lines. Looking at the equations, they all have just a number times x, just a number times x. The y-intercept is 0. Okay, in this T-chart right here, again, okay, do we have our 0? Well, we don't have our 0 in there, but if we look at our pattern, counting of 20 to 40, 40 to 60, 60 to 80, we're counting by 20 cents, we're counting by 1. So if I were to go up to 0 and subtract 20 cents, I would have my 0, 0. So if you'll notice that direct variation situations are exactly like proportional relationships, right? But what we're going to have to do today is we've got to learn to find that K value, that constant of proportionality. Okay, so when we looked at that square, the perimeter varies directly as the side length changes. So this right here is one of the things that we're going to be talking about today. It's more or less a vocabulary lesson. Varies directly. Anytime we hear varies directly, we're referring to a proportional relationship. Okay, so we have those same conditions that we talked about yesterday in dealing with proportionality. Okay, so direct variation, what it really means is y is going to vary directly as x does. Okay, so this y right here, it's going to have a consistent pattern as the x has a consistent pattern. So the answers or the outputs in our output table, the range, okay, is going to vary consistently as our x values change consistently. Okay, and we represent that using the formula y is equal to kx, where k is called the constant of variation, constant of proportionality, rate of change, slope. Okay, it's all of those different kinds of names. They all have the same thing. So we're learning a lot of vocabulary over the last few lessons that all mean the same. Right? So direct variation says for direct variation, two variable quantities are related proportionally. In other words, there's a consistency in the T-chart by a constant positive ratio. The ratio is called the constant of proportionality. Okay? So if we were to look over here, here's some examples. Here we got 8 is equal to k, 16 is equal to 2k, 24 is equal to 3k. Notice every one of those are saying the same thing. So I'm just kind of adding 2's there, adding 3's there. Okay, it's the same exact thing. So we can say in the algebra that y is equal to kx. So this constant of proportionality, this k, is equal to y divided by x. It's always the y value divided by the x value. Or whenever we looked at in the T-chart, we called it delta y divided by delta x. Well, we can actually even do that if I just take a point and take the y value divided by the x value, I'll get the same thing. Okay, so helpful hint. The graph of a direct variation equation is always linear. Okay, very important, always linear. Kind of reminds you of that proportionality. It's got to be a line. Okay, and always contains the point 0, 0. It must contain the origin. So it's got the same exact, okay, same exact definition as that for a proportional situation. Because direct variation means that it's going to be proportional. The variables x and y either increase together or decrease together. Okay, so if I were to give you some examples here, it says, what is the constant of variation? Well, in this first one, the constant of variation is, okay, and what we're talking about is the k value. So when we have y is equal to, k, x, I'm looking for that value right there. That is our constant of variation. So in this first one, the constant of variation is 3. In this one, it's negative 9. In this one, well, what value is in front of that x? 1, very good. And then the last one, it's 1/3. So those are the constants of variation. That's how we're changing. That's how we're counting in our slope when we're looking at our graph. So let's look at a couple situations and see if we can find constants of variation. So here is cost of Bob's graduation picnic. We have on the bottom, we've got the number of attendees and then how much it would cost based on the number of attendees. So we're looking for what is the constant of variation. Okay, well, what we do here is we pick a good point. We pick a point that actually looks good. Now, it's kind of hard to see the lines on this graph, but there's a good point right there. Okay, so if we look at this one, and if we looked at it in terms of slope, it would go up 30 over 10, okay, because this first line is represented by 10. So our slope, or our m value, would be 30 divided by 10. Well, our k value is going to be the same thing. It is going to be our y value, which in this case for this point is 30. Our y value is 30. And our x value is 10. Look, it's the same exact thing. Same exact thing. It's just when you're dealing with this value right here, the k value, you're always going to have a y-intercept of 0. Okay, so now if I were to simplify this, I would find our constant of variation. So k, when I simplify that down, 30 divided by 10 is 3 over 1. So what is our cost per attendee? $3 per attendee. Okay, let's look at another one. Okay, so in this one right here, again, the lines are kind of hard to tell, but there is a good point right there, okay, at 3, 2, or at 2, 3, excuse me. Okay, so I'm looking for what is the constant of variation. So again, we're looking for what is the coordinate of that point. Well, that point is 2, 3. So our k is equal to y divided by x. So in this case, k is equal to 3 divided by 2. Okay, and you'll notice that on this line, that is also our slope, up 3 over 2, up 3 over 2. Okay, and you would have another good point right there. Okay, so the k and the m are the same thing, but we're going to have a k, or a constant of proportionality, or a constant of variation, when our y-intercept is 0. So in this particular case, what is the constant of variation? 3/2, or if we're dealing with, like right here, we're talking about hours worked. Okay, we're talking about 1.5 hours. Okay, so let's look at some problems. Okay, sometimes they give you problems in word form. Okay, so some of the words that we've got to recognize is, suppose y varies directly as x. So when you hear those phrases, y varies directly as x, we're referring to a proportional situation. And there are two ways to solve this problem. There's the hard way and there's the easy way. Let's look at the hard way first. The hard way is looking at our formula. Y is equal to kx. Okay, well what we're going to do is we're going to take, it says if y is 3 when x is 15, then what will x be when y is 5? Okay, so what we're going to do is we're going to take this right here. This is a coordinate. X is 15, y is 3. And we're going to take these values and plug them into the y and the x. So I'm going to take this 3, I'm going to plug it into the y. I'm going to take this 15 and plug it into the x. And what I need to do is solve for k. Okay, that's what I'm looking for. How do I solve for k? Well, I have a multiply by 15. So how do I get rid of the multiply by 15? I do a divide by 15. So I do a divide by 15 here. Okay, so these 15s divide out, and we find out that k is equal to 3 divided by 15. But that simplifies to 1 over 3. So that's what our k value is. Okay, so now, using this k value, I now can figure out what x is when y is 5. So I go back to my formula. Y is equal to kx. Okay, and I'm going to take this value, 1/3, and plug it into k. So y is equal to, because I'm looking for the x, excuse me, so I know y. So I'm going to plug my 5 into y. I'm going to plug my 1/3 into k. And what I'm now looking for is x. So now how do I get rid of this multiply by 1/3? Okay, I do divide by 1/3 or multiply by its reciprocal. So I'm going to multiply this 1/3 by 3 over 1. Okay, so I'm multiplying this side by 3 over 1, and if I multiply this side by 3 over 1, I have to do the same to this side, and we end up with x equaling, well, 5 times 3 is 15. Now that's the hard way to do this problem. Okay, and you'll notice that is kind of hard. Well, the other way to do this, when we say varies directly, we know that means that it's proportional. So I can actually set up a proportion. Okay, so I'm going to set up a proportion of y over x. 3 over 15 equals, okay, and then now right here I'm going to do the same thing, 5 over x, and that's what I'm looking for. So I got to figure out what value will go here in x? Okay, and the way we solve a proportion is we cross multiply. So I'm going to cross multiply here, so I will end up with 3x equals, and now I have 15 times 5, which is 75. Okay, so if I divide both sides by 3, you end up with x is equal to 25 is your answer. All right, and that is the x value in y is 5. Well, let's look at another one down here. Okay, this one right here, we're going to do the same thing. This one says, suppose y varies directly as x. So that means I can set up a proportion. Okay, so when I do that, it says find x when y is 10 if y is -7 and x is -14. So there is our point. Okay, so I'm going to say that y is -7 over -14 equals, so now always remember it's y over x. So now my y is 10, my x is what I'm looking for. So now we cross multiply. So when I cross multiply -7 and x, I get -7x is equal to, and then now -14 times 10 gives us -140. I divide both sides by -7. That tells me my x value is going to be positive 20. And that's how we solve direct variation problems. We do it by setting up a proportion. Okay, so I hope this is, hope you learned something. Until next time.